Okay, class, Mr. Being here again, and we're now doing lab 12.8, mirrors and reflection. This is now part 4, the mirror equation and the simulation and the sims. I know you like doing sims. I'm going to go ahead and let you read this here. I'm not going to read it to you. I'll let you figure it out or let you read it, and we're going to apply these equations to what we just already constructed with our ray diagrams. So here's an example here. So here we have a concave mirror, and we have some initial information here. So let me go ahead and do our drawing tool. It says here the focal length is 6 centimeters. So that means from right here, 1, 2, 3, 4, 5, 6. So that's the focal length. This is 6 centimeters. And it says the distance of the object, DO, is 13 centimeters. So if this is 6 here, this would be 7, 8, 9, 10, 11, 12, 13. So about right here is where the image or the object is going to be at, 13 centimeters. And it says it's 5 centimeters high. So this will be 1, 2, 3, 4, 5. 5 centimeters high. Okay. Okay. In fact, let's maybe make it 4 centimeters high instead. Let me hit pause and let's go ahead and make that change. Okay, so I changed the height of the object to 4 centimeters. So we'll go here, there's 1 centimeter, there's 2, 3, and 4. So we're at 4 centimeters is the height. Okay, and the distance of the object is 13 centimeters from here. So let's go ahead and draw our ray diagrams. Okay, see what we got. So we'll go ahead and draw this out and make this as straight as possible. Hit here, and it should come right through here like so. This one here needs to be drawn. It goes through the focal point, hits here, and then it bounces straight back. And I'm hoping this is where the image should form. Okay, let me go ahead and maybe change. Well, we're right here, so I'm going to go ahead and say that the image is right here. Now, this is not drawn very good, so I'm not sure if this is accurate or not. But luckily, that's where the mirror equation comes in. And notice here, it asks us to find DI. So this is this here is HO, right? This is DO, distance of the object. Okay, this here is DI, that's the distance of the image, which we don't know what it is. And this here is HI, the height of the image. That looks terrible. Okay, there we go. HI, the height of the image. Okay, and in fact, let's get rid of that. Okay, this is HI right here. And over here is the focal point. All right, so we want to figure out what are these dimensions right here. Now, normally we would use the equation up here. So let me go ahead and let's erase this real quick. We would use the formulas up here, but I want to try to minimize calculations as much as possible. So we're going to go ahead and use this concave mirror calculator. Let's go ahead and use that, and let's see if that might be able to help us out here a little bit. Let's minimize that here. Let's minimize this here. Okay. And let me go ahead and kind of go here a little bit, like so. And let us do about 80%. Okay, and we have an add here, which we don't want to do an add. Okay, so we want to find out what is what's DI. Okay, so I want to find here, you can select object distance, focal length, or image distance. We want to find the image distance. Now, do I have the image distance here? Okay, and actually I do. The image distance is image, that's what we want to find. Object of the distance, object distance is 13, okay, we think it's centimeters. The focal length we know is 6, right? And we want to go ahead and it calculates it for us automatically. Let's go ahead and see if it's in centimeters here. Well, I think it's going to be in units that we give it. So if this is 13 centimeters, this is 5 centimeters, there's the image distance, 8.125. So we'll go over here and write down 8.125. Okay, there's the image distance, and it's okay, that's what it was here. Now the height, okay, what's the height here? Okay, and this doesn't tell us what height is, but up here we do have the formula for height. And let me go ahead and let's go ahead and do that here. So the height, we should do just a little bit of calculation here. So this says HI, right, is equal to HO right here. Is going to equal negative DI, right, over DO. Okay. All right, so we have some values here. I'm going to go ahead and pause, and I'm going to calculate it, and you should calculate it too, and make sure that we have the same answer. Okay. So when all's said and done, I have image HI. It should be negative 2.5 centimeters. Okay, that's the height of the image, and the negative sign indicates that it's upside down. It's upside or inverted, upside down, okay, or inverted, upside down. Okay, down. All right, so now let's, okay, let me pause again and we'll continue on. Okay, so before we get to this, before we get to the simulation, let's go ahead and let's revisit when the object is at the focal length. Okay, okay. Let's revisit when the object is at the focal length. Okay, and that leads to parallel lines and division by 0. So let me go ahead and clean this up here. Let's revisit when the object, or here, let me redo this again. All right, so let's revisit when the object is at the focal length. Okay, let's see what happens now. Okay, so here's our object is right here. Okay, and let's say it's, well, it's 4. Let me make it 4. So let's make sure that this is 4. Okay, and it's about like right here. And let's go ahead and see what happens here. Let's go and do our ray diagram, right? So this one goes here, and it's going to all right, let's go back here again. All right, over here. So the first, it comes through here, hits here, and goes through the focal point. Make sure it's straight as possible. The second one will hit the mirror about here, and it'll bounce like this, try to make it as parallel as possible. Okay, so we have this situation here, and these are parallel lines. Okay, so parallel lines here. Now let's go ahead and let's do the equation here. So it has 1 over the focal length here, right, equals 1 over distance of the object here plus 1 over distance of the image. Okay, so let's see where the image is here. Now, in this case, the focal length is 6 centimeters. So we'll go ahead and put this 1 over 6 here equals, the object is also 6 centimeters away. Okay, and here we have plus 1 over distance of the image. So if I do the math here and I try to solve for DI, I see that 0 is going to equal 1 over DI. Now, the only way this can happen is for this to happen here, that means that, you know, we have a problem here. We have a 0, and, you know, this presents a problem, you know, division by 0 situation. So for this to work out here, this implies that the distance of the image has to be at infinity, at infinity. Ah, at, this implies that di is equal to or is at infinity. So if this is infinity, 1 divided by infinity gives you 0. Now, if you were to try to do some math, and try to do this here, and you were to go 1 divided by 0, you can't divide by 0, this also implies that di is infinity. So it doesn't really, we're not saying that it's equal to infinity. It means that it approaches infinity. So as di, so di is approaching infinity, okay? And so parallel lines is a geometrical representation of perhaps why you cannot divide by 0. Pause. And this will be the end of part 4. So go ahead and do the simulation here. When you're through, do your answer, or make sure you use the calculator and do your final solution into the screenshot your answer in here.